Hello, welcome to short lectures in physics. Topic for a discussion in this session is measurement of atomic level dimensions. In another session, we discussed about indirect measurement methods of very large distances, and in this session, we are concentrating on measurement of very small dimensions like atom radius and nuclear radius. Let us discuss to estimate the radius of atom in an indirect method. So according to Avogadro's hypothesis, 1 gram atomic weight of all elements contain 6.02 into 10 to the power of 23 atoms. It is a molecule, so many number of molecules in 1 gram atomic weight of any element. And also all the atoms present in 1 gram element occupies only two-thirds of the actual volume of the substance weighing 1 gram, taking into account the gaps and voids between the atoms. So only two-thirds of the actual volume is occupied by the 6.02 into 10 to the power of 23 atoms in a gram atomic weight of any element. So now consider a gram atomic weight of an element. That means that the atomic weight of the element under consideration is a gram atomic weights. It contains Na atoms, and small r is the radius of its atom. Then volume of the one atom is equal to 4/3 pi r cube, and volume of atoms in 1 gram of element is 4/3 pi r cube into, because there are Na atoms in a gram atomic weight of element. So 1 gram atomic weight of element contains Na by A. So the volume of atoms in 1 gram of element is equal to 4/3 pi r cube of into Na by A. And also now considering the gaps between the atoms, the volume occupied by the atoms of 1 gram element is equal to two-thirds of volume whatever we calculated. That is, two-thirds V is equal to 4/3 Na by A into pi r cube. So radius of one atom is equal to R can be calculated as VA. V is the volume of the 1 gram element into A is the atomic gram weight, and then by 2 pi Na. Na is the Avogadro's number, that is 6.02 into 10 to the power of 23 to the power of 1 by 3. So radius of one atom as an approximate value can be obtained as Va by 2 pi Na to the power of 1 by 3. Number of molecules in 1 gram of water is equal to Na by molecular weight of water molecule. That is 6.02 into 10 to the power of 23 by molecular weight of 2 hydrogen atoms and 1 oxygen atom. So 2 into 1 plus 1 into 16, that is the atomic weight of hydrogen and oxygen elements. So that you will get it as 3.34 into 10 to the power of 22 molecules. That is the so many molecules are present in 1 gram of water. Now let us see radius of nucleus. How to estimate the radius of nucleus? Nucleus is the central core of atom, which is having protons, neutrons, and surrounded by electrons cloud orbiting in specific orbits or shells. So now take an alpha particle, which is a positive charged particle. 2He4 is an alpha particle. So let us make an alpha particle to collide head-on with the nucleus of the element under consideration. So in the figure you can see if r is the radius of the nucleus, then the alpha particle, as it approaches, because initially it has got some energy, with that energy, kinetic energy, it moves close to the nucleus. So as it comes close to the nucleus at a particular distance, that is known as distance of closest approach, the alpha particle slows down and momentarily stops at a distance r0. That is the closest distance of approach. Later, it moves back along its original path. When an alpha particle is outside the atom, the electrical potential energy is zero, as atom is neutral and hence no external electric field is produced. That means when the alpha particle is outside, nothing is happening. The alpha particle straight away coming close to the nucleus with some high kinetic energy. So as alpha particle approaches nucleus, it experiences a repulsive because both are positive charges. The nuclear part and the alpha particle are positive charges. So if m and v are the mass and velocity of the alpha particle, then its kinetic energy is k is equal to half mv square. So at the distance r0, the alpha particle stops and its kinetic energy gets converted to electrical potential energy. So electrical potential energy between two charges q1, q2 separated by a distance t is given by u is equal to 1 by 4 pi epsilon naught into q1, q2 by d. So in the present case, this electrical potential energy of this particular system becomes 1 by 4 pi epsilon naught. 2e is for the alpha particle, J is for the element under consideration, by R0 is the distance of closest approach. So that becomes 1 by 4 pi epsilon naught 2 J square by R0. According to law of conservation of energy, kinetic energy of m square becomes equal to this electrical potential energy. Thus half m square is equal to 1 by 4 pi epsilon naught 2 J square by R0. Thus R0 becomes the closest distance of approach. R0 becomes 1 by 4 pi epsilon naught into 2 Ze square by half m square, that is kinetic energy. So this R0 can be approximately taken as the radius of the nucleus because we are not directly able to measure at the present stage. So the radius of nucleus can be considered to be less than the value of the R0 whatever we got through this approach. So 1 by 4 pi epsilon naught values are given by 9 into 10 to the power 9, and E is given by 1.6 into, that is electronic charge, 1.6 into 10 to the power minus 19 coulombs, and 1 electron volt is 1.6 into 10 to the power minus 19 joules. So we can now make a note that R0 is proportional to atomic weight of the element, and it is inversely proportional to the kinetic energy. One more important thing from this observation we can make is radius of nucleus R0 depends on the kinetic energy we said. For higher values of K, it can approach very close to the nucleus because R0 is inversely proportional to K. K is high means R0 will be less, so it can go very close to the nucleus. And in this condition, the nuclear forces become predominant. Because it is approaching the nucleus, the nuclear forces become strong. This alpha particle also will be able to penetrate into the nucleus. So as a result, it will not go back along its uh, original path as we have seen in the earlier case. Thus, alpha particles with kinetic energy greater than a certain value cannot be scattered back by the nucleus. So it depends on the element and other things, and its kinetic energy, high velocity with which it is coming. It cannot be scattered back, and it will go and penetrate into the nucleus. Let us see one or two numericals in this section to understand the points what we discussed so far. Now we want to find out the percentage empty space in 1 mole of nitrogen gas at a standard temperature and pressure St. Given radius of nitrogen molecule is 2 angstrom units, that's 2 into 10 to the power minus 8 centimeters. So volume of one nitrogen molecule is equal to 4/3 pi into the radius is given, so 2 into 10 to the power minus 10 in meters square, that becomes 3.2 into 10 to the power minus 19 meter cube. So 1 mole of nitrogen gas contains Avogadro's number, that is 6.02 into 10 to the power 23 molecules as STP. So total volume of 1 mole of gas is equal to 3.2 into 10 to the power minus 29 into 6.02 into 10 to the power 23, that is 19.2 into 10 to the power minus 6 meter cube. So actual volume of 1 mole of gas is equal to 22.4 liters, is already known. So 22.4 into 10 to the power minus 3 meter cube. So volume of the empty space is equal to 22.4 into 10 to the power minus 3, that is the actual volume, minus whatever volume of the 1 mole of gas we got 19.10 to the power minus 6. If we subtract, we will get 22.38 into 10 to the power minus 3 meter cube. So the percentage of empty space is given by 22.38 into 10 to the power minus 3 by 22.4. Originally it's 22.4 into 10 to the power minus 3 into 100, that is 99.9%. So 0.1% is only occupied by the 1 gram molecules of nitrogen gas. So very large amount of empty space is available. 1 mole of nitrogen gas at ST. Now let an alpha particle with kinetic energy of 7.68 mega electron volts is making head-on collision with the copper atom whose atomic number is 29. Then let us find out the radius of copper nucleus. R naught is equal to 1 by 4 pi epsilon naught into 2 Z E square by K. So substitute all the values. 1 by 4 pi epsilon 9 into 10 to the power 9. 2 into Z is 29 into 1.6 into 10 to the power minus 19 square by kinetic energy is 7.68 into 6 mega electron volts into 1.6 into 10 to the power minus. So that gives 1.1 into 10 to the power minus 14 meters. 1 mega electron volt is 1.6 into 10 to the power minus 19 coulombs. So hope this finds useful to you in understanding the estimation, rough estimation of radius of an atom and radius of the nucleus in indirect methods. See you in the next session. Bye.